Okay, this is Sentential logic number, I don't know. This isn't the title there, I'm not sure. But this is another video where I'm going to be doing 4 proofs or derivations in sentential logic, or the logic system SD, where basically we have, we're just doing more problems, more proofs, and that's basically what we're going to be doing right now. At the beginning of the first video where I did problems, I picked 6 problems because they were shorter problems. But then the last video I did, I picked 4 because they were longer. The same thing I'll be doing here is picking 4. But first off, I want to kind of explain something where, let's say you have, if it says this, if it says this in a certain logic book, it does. The book that I use is called the Logic Book. It's by Mary Bergmann and some other authors. That's the one that I'm taking problems out of and using. And sometimes they'll put it this way, where we have this. These are the 2 assumptions that you are given, and this is what you are supposed to derive. On the other hand, you could have the following. So this you could have it this way, where you have your 2 assumptions and you have your thing that you're supposed to derive. On the other hand, it could be given to you where you have a set of assumptions where you could either have between 1 and 5 or whatever. You have 2 things here that we are supposed to use those things to derive that. So this is basically a derivability claim, where it's saying that we can derive this out of this. That's basically what we're saying there. So instead of, sometimes certain logic books, including the one that I am using, put it in these different ways. I just wanted to point that out before I went into the problems. And I know I'm using a pink marker. Hopefully that doesn't offend anybody. So we want to derive. We're doing the same thing. We want to derive E triple bar O ampersand O triple bar E. And what we have is, we have 2 assumptions. We have E horseshoe T ampersand T horseshoe O, and we also have O horseshoe E. These are both assumptions that we are given. So, like we do with every problem, we need to derive this from those 2. So notice that our dominant operator here is a ampersand. However, the 2 conjuncts that we have here are biconditionals. We have 2 biconditionals that make up the 2 conjuncts. So what we're going to have to do is we're basically going to have to make a triple bar. We're going to have to do a triple bar introduction. And notice that if you have E, you have O, and if you have O, you have E. So in a way, these two are the same thing. And that's going to be kind of going to help us. So what we're going to do immediately here is we're going to assume for E. sleeves up so I don't erase the board. It's cold in here. We're going to assume E. And why are we going to do that? We're going to assume that for triple bar introduction. And we're going to want to derive O. Now, notice here that we have E horseshoe T up there. We can just take that because this is a ampersand. So that's we can say E horseshoe T because of line 1 ampersand elimination. And boom, we have T. Because we have E, and we have E horseshoe T, so having E, and that means we have T. We have T because of lines 3 and 4, horseshoe elimination. And we also have T horseshoe O. That's also from line 1, ampersand elimination. And boom, we have O because of lines 5 and 6, horseshoe elimination. So boom, we got O. And now, anytime you don't understand something, if you have a question or anything, please comment below, because I'm not always certain that I'm doing a good job, or I'm not certain if I've messed something up, or maybe did something wrong, or made a mistake, because I've done that. I've done that a ton. Whether I'm on a test or just doing it, as practice. I mess up. So please tell me below if you see me mess up, or if you have a question or whatever. So please tell me. So now we've gotten it one way. We've gotten E to O. So we have to do it the other way. We assume O. For to bar intro, we want to derive E. And we kind of have that already figured out for us, because we have O horseshoe E, so boom, we have E. Minus 2 and 8, horseshoe elimination. So boom, we got E. And I like to do that. I like to do this little line here showing that we got what we, because when we make a sub derivation, we are assuming something to get something. And when we get what we want, I like to just make a little line here showing that we did get what we wanted. So from this, we can take E triple bar O, and that's from lines 3 through 7 and 8 through 9, triple bar intro, because that's what the rule of triple bar introduction is. We have to assume one to get the other, and assume the other to get the one. We basically do it both ways. So we have one of our conjuncts, but on the other token, we have the other conjunct too, because of the nature of the triple bar, we can also say that same thing. Or sometimes a logic teacher might want you to do this all over again, but usually not, because basically we have that. We have shown that we can get that. So we've basically got both of the conjuncts. This is kind of a weird problem, because usually you can't kill two birds with one stone like that, but in this case you can. Okay, that's basically it. Now, there are different ways that certain logicians do things. There are certain different ways that things could be done. Like, getting this might not have been so easy for certain people, and they might have wanted you to go do it a different way. But that's the way I've been hot, I guess. So I'll let it sit for a second so you can pause it if you need. And erase. Alright, problem number 2. This is a simple 9-line problem, 9-line derivation. We need to derive f ampersand g. And what we have is, we have two things that we can have at our disposal. The first is f triple bar g, and the other is f wedge g. Okay. All right then. So we have f ampersand g, and while we want to get f ampersand g while we have f triple bar g and f wedge g. So when you see a wedge that we have in our assumptions that are given to us, what you should usually think is that we have to do a wedge elimination. And a wedge elimination is going to go as follows. First thing we're going to do, assume f. For purposes of wedge elimination, and when I do wedge eliminations, I like to cite the line it was on, line 2, because sometimes you can end up with a lot of wedge eliminations inside of wedge eliminations. You know, you can have a lot of complicated things. So when I do a wedge elimination, I like to cite the line. I like to cite the line of the wedge that we are eliminating. So, what we usually in a wedge elimination, we want to get something different. We want to get the rule. If we have a wedge B, and we want to eliminate this wedge, we have assume A, try to get R, and assume B, and try to get R. We want to assume both sides and get the same thing out of both of them, but a different thing. So, boom. So we have this triple bar up here. So and we have F, which means we have G. Lines 1 and 3, triple bar elimination. And since we have F and G, we have both of the conjuncts that we want. Usually I would cite this also. We want to derive F ampersand G. That's basically that is our target. That is what we want. So that's what we're going to try to get through eliminating this wedge. So we have F ampersand G because we have F and G. Boom, got it. And now we assume the other disjunct. Boom, got it. And now we assume the other disjunct. Also assuming for wedge elimination line 2, derive so given that we have this triple bar up here, we immediately have F lines 1 and 6 bar elimination, and we again have both of our disjuncts that we want, so we can again go F ampersand G from line 6 and 7 ampersand elimination. Boom, got it. So then we can exit out of both of these wedge eliminations with F ampersand G. And when we are finished with a wedge elimination, the way we cite things is going to be it's very important, because we have to cite the original wedge, which is line 2, and then the first one, 3 through 5, and then 6 through 8 wedge elimination. Boom, we're done. Now that one is simple. I picked this problem because it shows the way a wedge elimination should be done and the purpose of it. I kind of picked that because it's a simple problem where we have a wedge elimination. So, any questions, comment below. I'm gonna give you a second to pause it if you need to, and erase. Okay, problem 3. We want to derive D horseshoe F horseshoe C. And we have two things at our disposal. The first thing we have at our disposal is a wedge B horseshoe C, and we also have the wedge E horseshoe F wedge G horseshoe A. Okay. Okay. Now, whenever you see horseshoes, there's one thing that you have to do, usually. Now, there's no rules that have no exceptions. There are always exceptions to rules. You know, there's no exceptions to the rules that we have, our 11 rules, but there are exceptions to things that we would usually do. When we have a horseshoe that we want to get, we would usually go with one of these horseshoe introduction procedure, but it's not always that way. I just want to point that out. So, boom, what we do first, assume D for horseshoe introduction. We want to derive F horseshoe C, and since we have the horseshoe within a horseshoe, we assume F for horseshoe intro. We want to derive C. Okay. Notice that we have D, so we can immediately go D wedge E from line 3. Wedge introduction, stupidest rule ever. And since we have D wedge E, we immediately have F wedge G horseshoe A from lines 2 and 5. Horseshoe elimination. And we notice we have F, so we can go F wedge G from line 4. Wedge introduction, another stupidest rule ever. And therefore we have A. Lines 6 and 7, horseshoe elimination. And basically what we're trying to get here, we're trying to get at this C. And we're doing all these wedge elimination or wedge introduction tricks to try to get at that C. And we're basically kind of plugging stuff together to try to get at that C. That's basically all we're doing. So, notice that we have A. We can do another wedge introduction. A wedge B, line 8, wedge intro. And then, boom, we have C from lines 1 and 9, horseshoe elimination. Boom, we got our C. So, having assumed F and got our C, we can exit out of this subderivation with F horseshoe C by lines 4 through 10, horseshoe intro. When we got this, then we can exit out of the whole entire wedge with D horseshoe F horseshoe C, because the whole thing of horseshoe induction is that we assume something and try to get inside of our subderivation the thing that we want, and we did. Therefore, we got that. And this is by lines 3 through 11, horseshoe intro. Now I picked that problem because that's kind of a problem where there's a horseshoe introduction inside of a horseshoe introduction, so that's kind of why I picked that one. By the way, the next video I'll be doing will be about theorems. A theorem is where we have none of these. A theorem is where we do a proof, but we have no assumptions. So that's basically what I'm going to do. Basically, what we'll be doing in the next video. The next video on derivations. All right, and let that sit for a bit, so you can pause it if you need to, and erase. All right, fourth and final problem. This problem is kind of a difficult one, I'll be honest. It took me a sec to get at it. It took me a sec to, figure it out, but I kind of been wanting to introduce some harder problems in these videos. Like harder as in 20-line derivations. This one is a 24-line derivation. Hopefully we can do this. I mean, I figured it out. It took me a while. So again, if you have any questions, let me know. I've been doing this for quite a while, and even I have difficulty with it. Even there are problems that I can't figure out sometimes. So I'm just saying that, if you have an issue you want to ask, a problem that you've been given in a logic class or anywhere, let me know, and I'll try and figure it out myself. So we want to derive E wedge F. Sounds pretty simple, but in this case, no. We have 3 assumptions. The first one being a wedge B, ampersand, I didn't like that one, ampersand, tilde C. The next one we have is tilde C, horseshoe, D, ampersand, tilde A. And then the final one is B, horseshoe, A wedge E. This one is not easy. 24 lines we got yet to do here. So what we're going to do first for lines 4 through 6 is we're going to do some simple plugging in and stuff like that. So immediately we can take this tilde C from line 1, ampersand elimination. Having tilde C gives us D ampersand tilde A from lines 3 and 4, horseshoe elimination, and let's see here. Also, what we need to do is, this isn't going to be of much, I guess, of too much use right now, but we also have to take A wedge B also from line 1. These 3 things will be of use later. So notice that we have this wedge. We have this wedge, and these things will be of use later. But this wedge we have to eliminate right now. So we assume A, for purposes of wedge elimination on line 6. We want to derive from both of these wedges B, and we want to derive B. We want to derive B for purposes that we'll see soon. We want to derive B so that we can get at that wedge, and we'll have to, once we get at that wedge, we'll have to eliminate that wedge too. And I'm worried that I'm going to run out of space here because we have 24 line, or we're only on line 8, and this is a 24 line derivation. Okay, so since we're after B, and we don't really have B just out for us, we're going to have to assume tilde B, purposes of tilde elimination. We're going to derive a contradiction, and we have tilde A we get from line 5, ampersand elimination, and we have tilde A from line 5, ampersand elimination. We have A from line 7, reiteration. Boom, we have our contradiction. We can exit out of that with B. That's from lines 8 through 10, tilde elimination. So we got our B with that one. We have to do a similar thing. Assume B for wedge elimination on line 6. This is pretty simple and redundant. We assume B, and we already have B, so there you go. And then we can exit out of those two. We can exit out of those two wedges with B, which is line 6, 7 through 11, and 12 through 13, wedge elimination. Do I have enough room? I don't know. So having B, we have A wedge E, lines 3 and 14, horseshoe elimination. So we're going to have to eliminate that wedge now. So what I'm going to do is I think I'm going to go up here with that. I go over here with that since I don't know how much space I'm going to have. So now that we have this wedge, we're going to have to eliminate that wedge. We have A. We're assuming that for wedge elimination on line 15. And what we want to derive from eliminating this wedge is E. And we want to derive E so that we can do the stupidest rule ever and slap an F on there. Notice we don't have F anywhere in our assumptions, so that's why we're doing this. So since again we don't have E sitting out, we're going to have to assume tilde E for purposes of tilde elimination, derive a contradiction. And how we're going to do that, we have, again, tilde A from line 5, ampersand elimination. We also have A from line 16, reiteration. Boom, we got it. We can exit out of that with E, line 17 through 19, tilde elimination. And we have to do the other one now. Have to assume E for wedge elimination from line 15. Derive E, another redundancy. And then we can exit out of both of those with E. And that's from line 15, 16 through 20, 21 through 22, wedge elimination. And we have E. Therefore, we can't do the stupidest rule ever. E wedge F, line 23, wedge introduction. Now that one is a little more complicated. I mean, it's simple, but it's complicated. So I'm sorry if this confuses you that I had to go up here with the rest of it, that I wasn't going to have enough room, as this was a longer derivation. So to kind of explain what happened here, as this might seem like all blur to you, as it usually might to somebody who, I mean, it usually does to most people anyway. It does to me with, you know, without understanding actually what all happened. So we got this wedge out so that we could eliminate it, and we eliminated that wedge to get B, so that we can get at that wedge. And being able to get at that wedge allowed us to get E by itself. And having E by itself allowed us to do the stupidest rule ever and slap an F on there. And that's mostly what happened here. That's just, that's the entirety of what happened here. That's a little more complicated because you aren't entirely going to think about that when you see this, or what you have to derive plus with your assumptions. But that's what had to happen basically. But mostly what I would recommend is looking at what you have to derive and looking at what your assumptions and strategizing with the 11 rules that you have. That is what I would recommend. Again, if you have any questions, any problems that you I guess need help with that you've seen in a logic class or whatever, comment below, let me know, or you can let's see, you could also send me a message, because messages, I could, if you send me a message, I could probably like connect with you better and kind of get your problems better than a comment. So definitely let me know, because I would be looking forward to solving more problems. The next video I'll be doing will be on theorems, and I'll explain. A theorem is basically like, a theorem is like, you have to, let's say you have to derive, again, you have to derive E wedge F, but you don't have any of those things. You have no assumptions. You have to do all of that by yourself. So that's what we'll be doing next video. Let me know again if you have any questions. Thanks.